Hi, everybody. Hang on, let me make sure I'm recording. Yes? All right, good. Just making sure. All right. Before we begin, a couple reminders. The assignment is coming up. Due date is Thursday. Get that to me by, the end of the day, 11:59 p.m. However you want to think about it on Thursday. I don't care what time, as long as it's submitted by Thursday. To submit it, all you got to do is commit back to the repository that you created. So make your project, get it all up and running, get it working, put it in your repo, commit it back. Basically, if you can log in to Bitbucket and see your code on there, I can see your code on there. So that's what we need you to do. Assignment 2 is actually probably not going to come out until next week. I believe that's listed for next week on the calendar, so we'll worry about that next week. Question?
Sometimes there are errors, when I was committing a studio, it would give errors during the commit process, small errors. It would work. I was saying it would give a warning. There'd be warnings and there'd be errors, but I wasn't even sure if I was regularly just building and putting on my emulator, it wouldn't give me those errors. I'm just wondering, do you take off for errors that will still run?
I'm not sure I understand.
I think one might have been a vertical constraint
wasn't set.
Yeah, but it wasn't in the one that we were told to do in the studio. It was stuff like that.
Well, for studios, it's a non-issue, but for the homework assignments, you're making these yourselves from scratch. So if you have a couple warnings when we run it, I'm probably not going to complain too much. I'm probably
when you do option enter and you can add suppressing stuff to get rid of errors.
So if that happens in a couple places, I'm probably not going to complain too much. If I see that stuff all over the place, then I'm gonna start taking points off, right? I mean, the professor in me is supposed to say that your code should compile and run without warnings, right? But let's be realistic. We've all been there. That doesn't always happen. I'm not saying that I'm just going to ignore all the warnings that get thrown, but a couple warnings isn't going to break my heart on these projects, as long as you are trying to be conscientious of them in general. That's okay with me. Are there any other questions about the homework assignments before we begin on today's material? Any other questions? Oh yeah, I had another announcement regarding the studios. A couple people asked me if I could post the studio code from last time because they wanted to look at it, and my answer was I was happy to do so. However, I was allowing people to submit those studios for additional credit. So here's the deal. I have office hours tomorrow. If you want to submit that studio for additional credit, please do so by tomorrow, or you can go tonight, actually. Taylor's in office hours tonight as well in the lab. Submit that. And because I'm going to post the studio for what number was that? 1? At the end of the day tomorrow. You're going to need it to work on the next studio anyway. I was going to have to post it no matter what. So if you want to get that done, do it sooner rather than later, please, because after tomorrow, I'm not going to take it anymore. And that'll probably be true for upcoming studios. Since they do build off of each other, there's only a limited amount of time for you to actually submit the completed studio to get that extra credit on those. So you'll have about a week after the studio. If you want to submit it, get the extra credit. If all you're going for is completion, then all you got to do is show up to class, work on the studio in class, and you'll get completion points for that. Is that clear? Question? We're gonna demo. We're gonna come say hi to you at the end of class on Thursday. Yeah. No, because last studio was before I made the changes. So this next one is the first one under the new guidelines. And everybody gets completion credit for the first two, whether they were actually here or not. Gets attendance credit for the first two, whether they were here or not. Any other questions I can clarify before we hop into today's material? No? Yeah?
It's obviously fine, but for dialogue alert, for example, Google stuff and decide it.
Go for it, yeah, for sure. There were some examples of that in the studio as well, though, that I have encouraged people to look at on the assignment. A couple people have come to talk to me about that. There was some confusion about the activities on the assignment. I just want to make it clear that one activity is okay. If you use pop-up boxes for stuff, I'm okay with that.
One activity is fine.
I believe so, yeah. I mean...
like the write-up specifically says to use an additional activity. There's like 3 points. Yeah, it's part of the rubric.
Is it?
Yeah. So you want to change it around.
No, well, but hang on. Because let me double check something here real quick, because the screenshots I feel like tell a different story, don't they?
It doesn't even give you the screen.
Oh, it doesn't.
Yeah.
Well, no, it gives you this one, enter total calories.
The first one, enter the calories, but it doesn't give you the screen for adding food. It just shows you once it's added.
Oh, it doesn't give you the screen for adding food.
So like.
I see. So I misunderstood. I thought people were making a different activity for this, and that's not necessary, obviously. So I'm not going to go against the rubric. I did not mean to go against the rubric just now. I misunderstood the question. If 2 activities is on the rubric, then that's what I want to see.
Okay, so for adding food, it would like bring you to another screen and then come back?
Yes. Okay. Yes, that's what's on the rubric. That's what I'm sticking to. Sorry for the misunderstanding. Apologies. We're pretty loosey-goosey. You know, if some people had emulator problems, if the pixel's not working for you, just find one that does and let us know what you did in your write-up. Like if you had to use a different emulator, just tell us. We'll figure it out. We'll get it to go. And that's basically always true. If you do something funky on your assignment, which is probably going to happen, just tell us. Tell us on the write-up. Don't let us load up your assignment and then have our minds blown because you did something really weird. Tell us about it in the write-up so that we're prepared and we can adjust accordingly. I'm happy to adjust for weird stuff as long as you're honest with me about it and you tell me about it in your write-up. Yes? How many creative portions do you need to add? Well, there's 15 points allocated for the creative portion, so you can take a look at the weight of that versus the rest of the assignment. There's 90 points total. Creative portion is 15 of that, so that's what? 1/6 of the total points? Did I do that math right? So think about how much work it was to do the entire assignment. Creative portion should be 1/6 extra added on top of that. If you want specific approval, I'm happy to do so. I think I mean it's hard to it's creative, right? So it depends on a lot of factors. There are certainly creative portions that could just be one thing that gets added that's worth the full 15. It'd have to be like a big thing, right? Or other people have done like 2 or 3 smaller additions that have also totaled up to the 15. If you're really unsure, come have a chat with me about it in office hours or on Piazza. Be happy to talk to you. Any other questions? Yeah, in the back. Architecture, setting up the projects. I mean, honestly, what I used was straight out of the Android documentation. So, oh my gosh, I cannot spell today. So if you look up, oh, that's for the operating system, not for the app, sorry. Totally different topic. Guide to App Architecture. I can't tell you how many times I've read this article. And there's other great articles linked within as well, right? I can't tell you how many times I've read these. They're extremely useful. Any other questions? Yes?
You know if there's either like one of the studios or like some examples done up, or whether we just have to Google it for bringing, like, so when we go to the new activity and then coming back, bringing that data back?
So I showed an example towards the beginning of class that had multiple activities, and then you can use intents to communicate information back and forth. So we talked, this would have been like maybe even on the first or second day of class. But for passing information back and forth, you can use an intent, and intents have data that can be passed along with as part of that intent. I know we talked about intents. Again, this would have been a couple weeks ago at this point, at least. So take a look at that if you're having trouble solving that problem. Any other questions? Okay, let's move on to today's material then. The topic for today is using web APIs and asynchronous programming within our Android apps. So I'm going to start actually with a little bit of just a very brief review of a topic that I covered at the end a week ago on Tuesday, just because I felt like I was running out of time. I didn't quite have enough time to do it justice. So I'm going to talk about recycle views for just one more minute. I know I've already talked about them a little bit. I'm going to talk about them a little bit more, just for a minute. And then we'll move on to web APIs and do some asynchronous programming. I'm going to use that same trivia app that I showed you last week that actually already has some web APIs and asynchronous programming in it. And I'll give you a big fat hint, right? A lot of the code that's in that trivia app is code that may pop up in the studio on Thursday. They were designed with each other. They were meant to mimic each other in a lot of ways. So if you haven't taken a look at that code, you might want to before showing up for Thursday's class. Just real quick, a reminder of our app architecture. So we have our activities, our fragments. That's the view part. That's the user interface part of our Android applications. We have our models. That's our data. So those are going to be Kotlin classes. And today what we're going to do, hopefully, is connect to a web service, right? And have a way of getting information from our web service into our models and using those in our application. And to bridge that gap, we're going to use some view models and some other techniques. So again, Android apps use the model, view model architecture. So the model is what holds our data. The view is what displays to the user, and the view model is what bridges that gap, explains how a model should be displayed. Next week, our topic's down here, SQLite databases. We're going to talk about that. So today, we're kind of here and here a little bit as well. That's our goal for today. But first, a very brief tangent back into recycler views, just real quick to review this. Recycler views are meant to replace, actually, list views. Eventually, I think you won't see list views around too much. A lot of you are using list views on the first homework assignment, which is great. Keep doing that. Don't switch now. That's totally fine. But recycler views have some advantages over list views, namely memory management capabilities. With a list view, once I've loaded some values into a list view, they're there. They're in memory, whether I'm actually currently using them or not. Can I help you guys? You, right there. Can I help you guys? I heard you talking. I didn't know if you had a question or... No? Okay. So a recycler view is meant to help, especially with that memory management process. It's going to unload things that are not currently visible by the user, and it's going to try to preload things that it thinks might be visible by the user very soon. So as I'm scrolling, right, any items that might be just off the screen, it's going to preload those so that when I keep scrolling up, they load very quickly. And as I scroll stuff off the screen, it's going to unload that stuff from memory. Again, memory management is very, very important when it comes to mobile apps because there just isn't a ton of memory to go around, right? There's just not a lot of resources. With computers, we can afford to be a little bit more cavalier with things because we've got a lot more resources at our disposal. That's just not true on the phone. So a recycler view is trying to help us out with memory management. But the way we set them up then becomes a little bit more complicated. Instead of using an adapter, I talked about this last week, using an adapter with a list view that translates how we want data to be shown inside of that list view, we're going to use something called a view holder instead, which is actually very similar to an adapter in a lot of ways. It's trying to accomplish the same goal. It just does it a little bit differently. So if you remember from my trivia app last week, there's an inner class down here at the bottom that's the view holder. This is the view holder. I have a very small view, a very, very tiny view that holds one trivia question and the possible answers, because they're multiple choice. And so, I mean, you could take a look at that in my resources folder. It's called the question item view. It is very tiny. It's got two things, two text views, one for the question prompt and one for the multiple choice answers, right? So a view holder, if I go back to that code real quick, what a view holder is doing is really just saying, all right, I want the choices from my model to be mapped up to that choices text view on my layout. That's what the view holder is. That feels very much like an adapter. An adapter has a similar process. I have to take data values and map them to the items in the layout. And so then the real magic is when you come up here and you take a look at the recycler view, right? So when I pass a list into this recycler view, it's going to create view holders for all of the items in that list. In this case, I have a list of questions. So it's going to iterate through that list, create a view holder for all of the items in that list, and bind them to that view holder, and then display them using a layout manager, which is up here. This layout manager basically says, is this a vertical list? Is this a horizontal list? Do I want to have, so I have a divider in this list, which is just a line in between each item. So it's just a little bit more information about how I want those view holders to be displayed in relation to each other. So the recycler view creates those view holders for me. All I have to specify is how I want the values to be mapped, right, to the various pieces of my view. And all of the rest of the code that you see here actually has to do with the part of the recycler view that's going to do the memory management piece. If I need to load more values, or if I need to, maybe my data set has changed and I need to reload it, how do I detect that and reload that data set automatically? The answer to that question is we use an observer. Here I have an observer, a class that all it's going to do is examine a list of questions and try to determine if it has changed. And all of these methods here are just used to detect if that list of questions has changed. So that if I'm binding that list of questions to a source that's on the internet, for example, and I pull those values down and they were different than the last time, it will detect that using the new list size or the old list size or the contents. There's methods for checking the contents of the list as well. Are items the same? That checks to see if the contents are the same, right? And if it detects that those lists have changed, the recycler view will automatically update for us on our behalf. That's where the recycler actually comes from in recycler view. So I just wanted to review that real quickly. I know I already went through some of that last time. It looks complicated. That's actually the downside of using a recycler view, is that the code to set it up is actually more complex than the list view, where I just had to create an adapter and then do my mappings, and I was basically done. Again, the advantage that we get out of it is better memory management and automatic recycling if it detects that the data bound to my list has gone out of date. So there is one of these in the studio. We haven't played around with it too much yet in the studio, but we may do so eventually. I just wanted to do a very quick refresher course on that before we hop into web APIs. Are there any questions on recycler views? And so then the last part of the puzzle here, which is going to be important to us today as well, as a matter of fact, is how do I get the data here in the first place? Nowhere in here do I see anything that says go online, grab a bunch of data, and then fill it up with this list. Yeah, question?
Are observers strictly or like?
No, actually, you can use an observer with any collection object, I believe. So any list, basically. If you want to detect those changes in that list, an observer can sit there and watch it. And if a change happens, then it can alert you that the change has occurred. And so if it's not tied to a recycler view, you might want to do something else with that information instead. Maybe not update a view, but maybe run a different query, or whatever the case may be. Great question. And so the question that I was getting to was, nothing in here says where the data actually comes from, and that's actually in a different part of the code for good reason. This all still has to do with views. I'm actually inside of the code for my fragment, right? So all of the code here is really just about the display. How do I properly display this information? It assumes that I am somehow going to be able to have a list of question objects to pass to the view to be displayed. But where do those questions actually come from? That's really the main topic for today. And part of the answer to that has to do with this question view model. So remember, a view model, if I go back to the architecture, is what bridges the gap between the model, which is my question object, and the view, in this case, the fragment. But it could be an activity as well. The view model is what bridges the gap. So the view model is in charge of actually making sure that the data that needs to be displayed in the view is there, is present, so that I can then pass that information to the view, and the view then knows how to display it. So if we take a look at the view model real quick, it's not very long, but you can see actually right up at the top, get questions, which calls another one load questions, right? And here is part of today's topic, asynchronous programming. That's actually what I was going to talk about towards the end. What I wanted to get to a little bit before that was, if I come down here, there's a particular piece of code I was looking at. This part right here, fetch question data. This is the command, and I'll show you this code actually for this method in just a moment. This is the command that's going to go off and do an API call to fetch information, to fetch data from the internet, and then it will populate a list out of that data and pass it to sorry, I just had a brain fart. Pass it to the fragment. So here's where you can see I'm instantiating the view model inside of my fragment code, question view model. So how do we do that? That's today's topic. Well, let's take a step back and talk about APIs real quick. Have any of you had experience working with APIs before? See, like maybe half a dozen. So for you, unfortunately, this is going to be review, but I am going to do a pretty thorough discussion of APIs up front for the people who have not dealt with APIs before, just so we're all on the same page. So an API stands for Application Programming Interface. You're actually probably first introduced to them in 131. Java has a very well-written API that explains what all of the methods and objects and everything in Java can do for you. That's really not the kind of API we're talking about today. We're talking about an API that allows communication between different machines, or the computer science-y term for that is interoperability. That is the ability to exchange information across computers. It's a harder problem than it sounds like, because no two machines are created alike, right? So there's different types of web APIs in the world. SOAP has been around for a while. A decade ago, when I was where you guys were sitting in school, we were using SOAP APIs. Not used as often today, but still in use. SOAP uses XML, actually, as a way to transmit messages from one machine to another. The same kind of XML that you see in the manifest, for example. That's all XML. We're not going to use SOAP, though. We're going to use a different kind of API, the one that's become far more common lately, we're going to use a REST API. And so let's take a minute to talk about what we actually mean by a REST API. REST, I hate this acronym, but it is what it is. Representational state transfer is what it stands for. That representational is kind of an interesting piece. It's actually, even though state is part of the acronym, you can see that one of the design principles is that it is stateless. The API is stateless, meaning that it is not remembering any information about who you are or what queries you've made in the past. It's not going to remember you. It's not going to know who you are when you make another query. So each query then kind of stands alone by itself in a REST API, right? It does use client-server architecture. That's the one that I feel like is the simplest to understand. In this case, our apps are the clients. The API is the server. So if I'm making an Android app, I want to use some information on a web API, I'm going to make a request and send it off to the server. The server is going to process my request. Hopefully everything's valid and runs well, and then it's going to package up the information and send it back to me. REST information is considered to be cacheable. So a cache really just means if I want to, or as an iPhone app or any other machine communicating with the API, could keep a copy of the data that was sent. That's called making a cache, right? I don't want to have to fetch the same data over and over and over again. I can fetch it once and keep a copy for myself, but I need to have some sort of mechanism in place then to know if the data that I have is no longer consistent with the data that's on the server. That's an important part of cacheability. Now, in some cases, we may not care, right? Our trivia app is actually a good example of an app that doesn't really care about cacheability. If the questions on the server change and I have an old batch of questions, who cares? It doesn't matter. But if I'm dealing with more timely data where time is an important factor, then having this ability to discuss with the server whether my data is up to date or not is important. REST APIs are considered to be layered systems, and what that really means is that they have the ability to scale. So I talked about client-server architecture, but it may not be just one server hosting that API. It may be a bunch of servers hosting that API for performance reasons, to handle the perhaps thousands, millions of requests coming into that API. I would want more than one server available to handle such a large load. But from the client's perspective, to me, it just looks like one server. It makes my life easier to just treat it as one location, one server. So that's what we mean by a layered system. Code on demand is a design principle that I actually have not seen that much in practice, but in theory what it means is that if I wanted to request code from the server to be executed as part of my application, it should be theoretically possible for me to do so with a RESTful API. Again, I have not seen that implemented very often in practice, but that is one of the design principles with a REST API. And then last, but certainly not least, in fact, probably the most important for us, is a uniform interface. In fact, a lot of people will say that it goes a little bit deeper than that. If I'm able to connect with a server hosting a REST API, I should be able to talk to that server and get a full view of how to interact with that API. So there shouldn't be any guessing involved on my end. The server should be able to fully explain how it's going to work. And you'll actually notice as you start working with more and more APIs that the interface that you see on these APIs does tend to be fairly consistent from one to the next. So let's take a look at that interface. How do I actually talk to these web APIs? Well, there's always going to be a base URL. So wherever the API is hosted, that's going to be the base URL. And so for the trivia API that I use to make the trivia app, there's the base URL. In fact, you can open that up in a browser. I think I already have it open up in a browser. Well, this is a slightly different page, but if I try to open this up directly, here it is. It's blank. It's blank. Because the base URL oftentimes is not enough to be a fully formed request. I need to provide more information. What exactly am I looking for? What information specifically am I looking for from this API? I haven't actually given it any parameters. So I'm forming a search, basically. And so if I want to, where did my slides go? Whoops. If I want to provide more information, I can stick a question mark on the end of the base URL and then provide parameters. How many questions do I want? Amount equals 10. I want 10 trivia questions. What category do I want them to be in? Category number 17. What category is that? I don't know. Obviously, the categories have been numbered. I don't know what that category actually is. I did when I made the slides, but I already forgot. What difficulty do I want them to be? I want them to be easy questions. And so if I take this and plug it in to my browser, I get something back that looks like this. And we can pick out a question. Igneous rocks are formed by excessive heat and pressure. That's something I learned from Bill Nye back in the day, right? Actually, that's is a false statement, I suppose. What is the one that are formed by excessive heat and pressure? I don't remember. Bill Nye has failed me. Or I have failed him, actually, is what happened. I shouldn't put it on Bill Nye. But anyway, these are the trivia questions that I requested. This is not a format that we've seen before, but it's definitely a format that you're going to see in many different places going forward. This is a format called JSON. JSON. So we're going to talk about that in a little bit more detail. But before I do, I just want to make sure we're all clear on the how to, whoops, I clicked the link. How to interface with a web API. Does anybody have any questions about forming the URL? And so I don't know how many of you have taken web programming or understand how the web works or anything like that, but there's two basic web requests that we can make. These requests are what I would call GET requests. I am wanting to receive some information, wanting to get some information from the API. So I have issued GET requests that tell the server what exactly it is that I'm looking for. It receives my GET request, and as long as everything is formed properly, I'm not asking something that it cannot do, it will satisfy my request and send the information back to me. The other kind of request that you see on the internet is called a POST request. A POST request is me as the client sending some information to the server. So if I want to make changes to the data that's on a particular server through the API, I can oftentimes use a POST request to actually manipulate data that's somewhere else. Not all APIs are going to let you do that. This API is not going to let you mess with its data, right? But if you create your own server with your own API, then you certainly could create POST requests, POST access points to allow you to manipulate the data that's stored on your server. For the purposes of this class, we're going to stick with GET requests primarily, at least for now. So where do these come from, right? How do I know what these values should be? How do I pull those out? You got to look at the documentation. So if I go back to the trivia database, there's a documentation link here that specifies exactly well, okay, maybe not. Maybe not here. Where was it? It must be down here then. That specify exactly what parameters are available. Number of questions, category, difficulty, select type encoding. This API is kind of generous. These are all drop-down boxes. I can select whatever I want, right? And then have it specify, or it will create the URL for me. There it is. It created the URL based on the options that I specified. But if we're creating an app and we're trying to do this on the app, we don't have that. We don't have that ability. We have to create that URL. We have to make that happen. And I'm going to show you how I do that in the app in just a moment. Right? But first, let's look at some video game trivia. First Call of Duty title. Who plays first-person shooters? Not me. Half-Life? That was an okay game. Oh, wait, that was a first-person shooter. In Super Smash Bros. For the Nintendo 3DS and Nintendo Wii U, who was the 6th fighter to be added to the game post-launch? Who cares? Was it Shaggy? I'm too old to be saying stuff like that. All right. Anyway, sorry. So what we got back was JSON. Let's talk about JSON for a minute. Stands for JavaScript Object Notation, which, JavaScript is where the origins of JSON are from. But I don't use JSON with JavaScript very often at all these days. I do use it with JavaScript. Actually, I kind of don't like JavaScript, but that's a different story. JSON is used for all kinds of things. It has been sort of adopted as a very nice way of formatting data that needs to be sent. So the way that it works is we format everything as key value pairs in the JSON data set. But not only that, it gives us the ability to do lists of data, and we also can embed objects within other objects. Let me show you an example to help make this point clear. Here actually is another example of what JSON might look like from the Trivia API, but just formatted a little bit nicer so we can actually see it a little more clearly than what I had up on the screen in the browser. And so you can see the first thing that it sends us is response code 0. I'm not actually sure what the response codes mean for this, but I'm assuming that response code 0 means that everything was okay. There were no problems. And then the results. Now when I see a square bracket, that's a list. That's a list of items. In this particular case, you can see I actually only have one thing in this list. It looks like there's a lot of data here, but it's really just one object. So the curly braces signify that I've got a new JSON object. And in particular, so the structure of this, right, is I have a JSON object embedded in a list, which is embedded in another JSON object. And I can do that as much as I need to set up the structure of my data. Embed lists inside of objects, objects inside of other objects, objects inside of lists, et cetera, et cetera, et cetera. So within this JSON object, I've got more key value pairs. What's the category? What's the type of question? How difficult is it? Right? Here's the question and the answers for that particular question. This is the other important part about using these web APIs. I have to understand the format of the data that I'm going to get back. I have to know what these keys are. I have to, because otherwise I'm not going to know how to fetch the data out of this JSON. In other words, once I receive this JSON back in response to my request, I have to parse it. I have to go through that JSON and pick out the pieces of data that I need to perform whatever it is that I'm trying to do with this information. And so I'm going to show you how to do all that in an Android app. But first, let's try a little exercise. There's a Pokemon API for the Pokemon card game. And I want you to take just a few minutes to read the documentation of the Pokemon card game API. Right? I intentionally gave you another API so that you'd have to do a little bit of work. And I want you to answer a couple questions, which I navigated away from when I clicked that link. See if I can get them back. These questions should be fairly straightforward to answer. It should not be terribly complicated. I want to see all of the water type cards, and I want to see all of the Squirtle cards. These are two separate things. You'll have to form two separate URLs to make this happen. But take a few minutes, talk to your neighbors. You don't have to do this by yourself. I'm not grading this or anything, right? go to the documentation, see if you can form the URLs that will answer these particular questions. And we'll go over the answers in a couple minutes. I'll be around if you have any questions or you need any help. All right, so these were not meant to be complicated. They were meant to be pretty straightforward, just to get you to look at the documentation a little bit, see if you can understand how this API works. A lot of APIs feel very similar to each other, but they do have their differences, subtle differences in terms of what's available. So first thing you need to locate is the base URL, right? And that was given to you up here at the top for this particular API. So here's a base URL that we can use, and now we just need to figure out how to make a particular request that will answer the questions that we're interested in. So I asked for what, all water type cards? Well, if I scroll down here to the documentation for the cards, it looks like this will get all cards if I just leave it as is, and there we go. That's a lot. I actually think that it limits you to 1,000 cards, so this may not be all of them. I don't know how many actually were in this particular set, but anyhow. But that's not what I wanted. I wanted, all the water type cards. And so you can see there's a parameter types, or there's another parameter name that might help us out with the second one that we need to tack on to our query in order to properly form our request. So how do I add parameters onto the end of this URL? Question mark. and then I say types equals water. And now we have a list of all of the water types. I know this information, right, is hard to read. You're not meant to sit down and read it, right? You got to parse it. Once you get this information back, you got to go through, parse the information, get what you want out. But you can see that if I look for types, it should say, or I guess I should look specifically for water. You can see water, right, popping up all over the place in this data set, which is what we requested. This is what we requested. And so, you know, for the second question to get information about Squirtle cards, I would use the name parameter instead. Name equals Squirtle, and this should give me information about Squirtle cards. Not as many, what, maybe a couple dozen or so, 10 or 20 different cards available. And information that is about all of those cards. Are there any questions about that before I move on to the next piece? Okay, if there aren't any questions, let's take a look at how to do this in our app. We haven't even touched our app yet with this API stuff, so let's take a peek and see how we can do that. I actually have two API calls in the Trivia app. One that just grabs the list of categories, and one that grabs actual trivia questions. So I'll show you how to do both. In general, we want to keep our API access in a single place. It just makes our life easier in terms of organization and code readability. So oftentimes you'll see a file called query utils or something along those lines. That's where the API calls are going to go. And we'll see kind of a similar setup next week when we talk about databases too, for the same similar reasons. So what am I going to see inside of query utils? I'm going to see the actual API calls. In order to make those API calls, right, I have to send out a request over the internet to that server. And then that's going to give me some data back, which I then have to sift through to get the information that I want. I have to sort out all the information. And then ultimately, what am I trying to do? I'm trying to create my models. Remember in this Trivia app, I had two different models. Or did I just have one? I can't remember. Oh, no, I had two. Categories and questions. I have two different models. So my ultimate goal, right, is to create models based off of the information, instances of these model classes based off of the information that I'm pulling from the API. I can then take these models, pass them to the views, using a view model, if necessary, to have them displayed to the user. That's the idea behind what we're doing. So let's take a look then at the query utils to see what's going on in there. I made a util package with query util. And you can see up at the top I've got some constants, one of which is the base URL. There's the base URL for my trivia database. And so I've got two different functions next, one that says fetch category data and one that says fetch question data. And both of those take in a string as their parameter, as the parameter of the function, which that's going to be the question mark such and such stuff that gets tacked on to the end of the query to make the specific request that I'm making. So you can see the first thing I'm going to do is make a URL with the base URL and the query string, the parameters, right? Then I'll try to make this HTTP request. I'm basically saying send this request off to the internet and take the results and store them in this variable. Now, you know, we're sending stuff out over the network. Problems can happen. Maybe I'm not online. Maybe the server isn't there anymore. Maybe it's down temporarily, right? So we have to be aware of that fact and handle errors. But assuming this request goes through successfully, then I have another method that says extract this data from this response. This is where the JSON parsing is going to occur. And that's where I need to have some information about how my data is structured. So before I can actually incorporate this into the app, I need to test a few API calls and get a feel for what the structure of the JSON is going to be so that I know how to properly parse it. And so if I, oh, okay, actually I shouldn't skip over this real quick. Make HTTP request is going to use an HTTP connection and set the properties that we want. Why, get out of the way. Including timeouts. There's the method, request method get, right? I'm making a get request. That means I'm requesting information from the server. If I was sending information to the server, I would switch that to be a post request instead. But I'm setting the properties. How do I want this request to work? A lot of this is boilerplate code. And in fact, this is probably one of the areas where I'd say, you know, if you need to make these kinds of requests, keep this code handy because you can just drop it into your apps. There's no sense in trying to reinvent a lot of this stuff. It's just going to be boilerplate for a lot of your apps. Okay. And so what I really want to get to is extracting data. So this variable that comes in, that's JSON. That's JSON formatted data, which is fine, but my ultimate goal is for that to take that data and do what with it? What am I trying to create with that JSON data? Yeah. The model. Yep. In this particular situation, I'm trying to create category models. I've got another method down here somewhere. Is it this one? To make question models. So I can make both. And actually, the question model, I think, is a little bit more interesting than the category model. The category model is very, 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 very small. The question model is not huge either, but anyway. So I have to understand what it looks like. Let me see if I can pull up the structure just so we're aware, right? These are the keys. So I'm going to be looking for these keys inside of the JSON, pulling these values out, and passing them into a question object. You'll notice, though, that some of these are lists. So this is actually a list of values, right? I want to make sure I capture the entire list. That's going to be a little bit different in terms of processing versus when I just have a single key value pair. And so let's take a look at how this code actually parses it. Thankfully, parsing JSON has become such a common thing that there are convenience objects available for us to help us out. So things like getJSON object is going to get, remember, an object in JSON is anything in between curly braces, stuff that's in between curly braces. So we're going to grab the first object out, and then we're going to look for the incorrect answers. I actually did that first because that's the one that's going to require a little bit more attention since it's a list of values. It's not just a single value. It's a list of values. So this code says pull the incorrect answers out of this JSON. Remember, that's going to be a list. So I'm going to iterate through that list that I've got and add them to my list of strings that will eventually get passed to a model. For other key value pairs, if it's just a straight key value pair, there's no list or object involved. It's actually a lot more straightforward. You can see that what I'm doing down here is just querying directly. Give me the value that's associated with the key called category. Give me the value that's associated with the key called type, right? And I'm also casting them to the data types that I need to match in my model so that they don't have cast exception errors when I try to take stuff out of the JSON and put it into my question model. But this code, this snippet of code, is actually creating, there it is right there, a new question object. Each line is pulling out one of these values, right, and passing it into this new question object that I'm creating. And I'm just going to keep doing that until I've gone through the entire response, until I've visited the whole thing. Does that make sense, what's going on here? So for simple key value pairs, right, just a single query for that key is enough. But if I'm expecting a list or even an object as the value, then I got a little bit more work to do. I'm going to pull that back out as an array, and then I have to iterate through those values and add them to a Kotlin array list or a Java array list or whatever it is that I'm actually using. Are there any questions about that? Any questions? Yeah.
Yeah, I think I know. I just want to be sure though. So like, is the reason that you're doing return value or default?
Oh, okay. I can actually show you that method. Yeah, I sort of glossed over it, but let's not gloss over it. Let's take a look. It's basically allowing me to specify what I want default values to be in case I don't find that key. So it's possible for whatever reason that I say, give me the value for this key, and it can't find it. So I've got options there, right? If it can't find it, I could just let it crash, but that's kind of bad. So what I've done instead in this particular class, in this particular method, is say, well, all right, if you can't find it, there's a problem, then just give me an empty string instead, or give me a -1 if it's an int, right? I have different default values depending on what the data type of that is supposed to be. And again, too, a lot of this is fairly standard. A lot of this is fairly straightforward. You're actually going to see this utility class in the studio on Thursday. And so you're going to see a lot of this code again. Question in the back. So inline function is, let's see, I know what it's supposed to do in Java. I would imagine it's going to do the same thing for Kotlin. I would imagine it's just an optimization, but let me double check just to make sure. Inline functions and reified type parameters. That's exactly what I wanted. Let's see. Inlining. So when I inline a function, are you guys familiar with what it means to inline a function? You guys familiar with that term? It's a performance improvement. Basically what it means is instead of jumping to the function execution and then jumping back once the function has returned, I'm going to take that function body and rubber stamp the whole thing in every time I call the function. That's what's called inlining. So basically I wrote a function, but when it gets compiled and executed, it's just going to rubber stamp that function in the code every time I need to use it. It eliminates the function call overhead. That's what happens. A lot of times your compiler does that for you automatically. It's just the inline keyword allows you to force the compiler to do that, whether it wants to or not. It's a performance improvement. Anyhow, it can also prevent the compiler from optimizing code away, things like that. Good question. Any other questions about this code? Again, I just want to make it clear, a lot of this code is fairly standard. You're going to see this code or similar variations of it when you do JSON parsing, including on the studio. Yeah, do you have a question?
Yeah, talk about the return if.
Where do you see that? Oh, return if.
Line 183. It's like, why is the return statement not on line 184? Why is it on 184?
Yeah, this is just shorthand. It's returning an if statement. It's basically giving me a conditional return. If this has a key, then I'm just going to return whatever value I get. If it doesn't have a key, I'm going to return this default value. It's just a little Kotlin-y syntax. Conditional return statement. Yep.
So it's like a ternary operator.
Yeah, I could see the similarities there. I mean, if it bothers you, right? What's the equivalent statement would be to make a variable store these results in that variable and then return it after the if statement. That would be an equivalent way of getting about it. Just a little bit of Kotlin magic going on there.
So then, like with the in class, there's like you scroll down a little bit.
Yeah, there's a different default value. It's basically allowing us to check the type.
But then,
That's what this reified is doing, right?
Yeah. But then, so like, there's a return on line 194, but not on line 186.
Oh yeah, I'm actually not sure. Is that necessary? I don't think that's actually necessary.
Okay, yeah, that's it.
Yeah. I think that might have been a little redundant. Of course, it didn't seem to complain about it either. Yeah. Old habits die hard, for sure. Any other questions? I'd be happy to answer questions about this code. You also have it available to you on the website too, so feel free to download and take a look. In fact, if it hasn't become clear already, I would very, 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 very highly encourage you to download this code and take a look at it before coming to studio on Thursday. It's going to help you out big time for the studio on Thursday. There's still actually a couple parts of the code that I haven't shown you yet that I'd like to discuss as well. There was actually a piece that I glossed over a little bit earlier. Let me see where I'm at in my slides, though. I want to make sure I don't skip anything. All right, yeah, let's talk about this. Asynchronous programming. How long does it take if I form that HTTP request and I send it off to the server? How long does it take for that to run? I don't know. Some amount of time, right? Is it more or less time than I would expect, you know, a line or two of code to execute? What do we think? More, right? More. It's more time. So the question is, should we wait for that request to finish and come back before we do anything else? And the answer is no. That's wasted time. Think about what that would mean. Think about what that would look like. You might have actually seen this before. I hope not, but it's possible that you've seen an app where it has to do some work on the internet, and so the whole thing just freezes until it's done, until that information comes back from the online query that it made. That's bad design choice. That's bad UI. We could use asynchronous programming to get around that. So if we're using a lot of web API calls, which we're going to be doing this week, what we can do is we can form our request and we can say, all right, go off and do that. I'm going to go do something else, right? And then when you're done, you just let me know, and then I'll process the data that you got back. That's asynchronous programming. I've got things that are multiple things happening at the same time. I've issued a command and I don't even know when it's going to be done. It's asynchronous, but I'm not going to wait for it. I'm going to keep moving on. And so let me show you how that works. I think that shows up a couple different places in the app. Anytime I need to make an API call, it's actually going to happen in the fragment code, which is going to be in either question list or trivia form. Wait, no, I'm sorry. We saw it in the question view model, rather. But it's also in trivia form, too, I think. Isn't it? Yeah, it is. So in this particular class, in this particular section of the code, I'm fetching the categories. What trivia categories are there available? I don't know if you remember the app from last week. I don't actually have it running right now, but there was a drop-down list that I could pick the category of trivia question that I wanted, and I pulled that list from the API. There was a query I could make from the API to pull that list. So here is where I actually do that. I made an asynchronous task. And you can actually see here, when I load the categories, it creates this asynchronous task and executes the query. In this case, the query is whatever parameters I need to add on to the base URL to grab the list of categories. So what does this asynchronous task do? I'm overriding a couple of different functions. This first one, do in background, is quite literally what I want this to do while I go off and do something else. The rest of my program is going to go on and do something else. A lot of times, honestly, what's that something else going to be? that something else is going to be just keep the thing from freezing, right? Just don't let the UI lock up. Let them still manipulate stuff on the UI if they want to. So it's going to run this in the background, and you can see it does a call to fetch category data in the query utils. So that's where it forms the API, right? Processes the JSON, creates the list of models, right? And then gives me back the data. And then the next function is, okay, what do I want to happen when I'm done with that? I don't know when this is going to happen, right? I don't know when it's going to finish. It's going to take some amount of time. I actually have no idea when it's going to finish. But whenever it is finished, what do I want to happen with that data? So hopefully I get some results. Hopefully results are not null. And if they're not null, in this particular case, what do? I create a list of those categories, and then I add them to the spinner, which is what Android calls that drop-down menu. I just add it right to the UI, add it right into the spinner, so that I can now use that drop-down menu and see the categories that are in it. For the question, so there's another async task over here, right? You can see that all it does is it actually stores it in a variable. It doesn't do anything with it. It just stores it in a variable. And then when I need to access that data, such as I need to do in the fragment, I will grab the view model and then pull the question list out of it. Out of that view model. Hello? Get questions. Oh, that's actually what starts the API call. There you can see the parameters that are going to be passed, tacked onto the base URL. Yep. Anyhow. So that's how we use an asynchronous task to perform these queries, and what it provides, hopefully. I thought I started this while I was talking, but apparently I didn't. Sorry. It's going to do a quick little demo of the app. That's what allows the app to keep functioning without locking up while we wait for those API calls to come back. Because it could take a while. Oh, well, okay. So are there any questions about that? Basically what that means is if I'm making an API call, I should really create one of these asynchronous tasks and then specify, I'm sorry, I scrolled away from it. I should create one of these asynchronous tasks and then specify, what do I want this task to do? What is it that might take a while? Put that in the do in background function. And then what do I want to happen when the task is finished, when the API call is done? It might just be, save it for later. I'll come and get it. Or it might be, oh, load it up into the UI. Something like that. Are there any questions? No? Okay. I'm almost out of time, but I did have just a couple other things. Oh yeah, permissions. Let's talk about this real quick. To kind of wrap up the day. May have touched on this a little bit last time, but in order to make these calls, I need to access the internet. And in order to access the internet in my app, I need to have certain permissions listed in my manifest. And so you can see that it needs to access the network, the Wi-Fi, the internet as part of the app. And then there's also the question of, well, what happens if I try to do this and there isn't internet? I don't have any internet available. We need to accommodate for that. Actually, that's a pretty simple thing to do, but I'll show it to you for the sake of completion. I've got another fragment here. It's called my no connection fragment, right? It's very simple in design. I believe it just says no connection here in the middle whenever it decides to load up. I'm not sure why it's not showing it, but anyhow. no connection. And so then if I go look at my main activity, I do a check. Grab the connectivity manager. I want to get online. So I'm going to grab the connectivity manager. I'm going to see if I can get the information for the active network. Can I get online? If I can't, this will be null. So I'm going to put up a message. I'm going to put up a no connection fragment that says, hey, you don't have the internet. If I am connected, then I'll go ahead and load up, whatever it is that I need to load up, which in this case would be, looks like the list of questions. Actually, there should be another one for, here's another one for the first activity where you fill in the number of questions you want in the dropdown. And so if I disconnect from the internet, is that going to break anything if I disconnect from the, I think it'll be all right. I can get off the internet for a minute just to test this out. Maybe. If I get off the internet and try to run this guy, oh, come on. It's going especially slow today. There it is. Although it shouldn't have loaded. Well, that clearly did exactly what I expected it to do. Not sure what happened there. Or maybe it just hasn't timed out yet, or I'm not sure what happened. Oh, the phone still thinks that it's online. That's the problem. The emulator thinks that it's online, even though my laptop is not. That's why it didn't show the appropriate message. I could go in and turn off the Wi-Fi on the phone emulator, but I think you guys probably get the idea without having to see that happen. What questions can I answer for you about this stuff? We covered a lot of ground today. Covered a lot of ground. Showed you some APIs, show you how to interact with APIs, and then we dove in and looked at how to communicate with APIs in our Android code, how to connect that up with our view models and our views ultimately to display the information that we get from the API after we parse the JSON, and how we can do that asynchronously so that I'm not holding up the other parts of my app while I'm waiting on that internet request to go through. Do you guys have any questions? Yeah?
Why do you use frag placeholder?
Frag placeholder. So frag placeholder, this is actually mimicked directly after the studio, as a matter of fact. Frag placeholder is a placeholder in my main activity that I use to swap out whatever fragment I want to be currently active. So if I'm on the trivia form screen, I'm going to put that in the placeholder location. That's like, it's like the, I don't know how else to explain it without using the word placeholder. It's just keeping the seat warm as I load other fragments in as I navigate around the app. So when I hit the button to submit, this is actually what get questions is. This is the function that fires whenever I hit the button to grab a set of trivia questions. It does the same thing. It's going to load up the result list, the question list, into this frag placeholder. So everything goes there basically in this app. If I'm using this fragment structure, it's a pretty typical way of going about it. Yeah, it's a pretty typical way. The studio does the same thing. I believe Taylor talked about that a little bit last Thursday as well. Studio uses the same piece. So this is a little bit different than some of the other apps we've seen, though, right? I've got one activity, and I'm just swapping fragments in and out of that activity, as opposed to navigating to an entirely different activity. And it makes sense in this context, actually, because consider I'm never going to get to this question list without going through the form first, right? In other words, I can't really have this list of trivia questions without having the API query screen come first. They're linked. They're very strongly linked together. So because they're coupled so tightly like that, it does not make sense to split them off into different activities. It makes more sense to have one activity and then just swap those fragments back and forth as I need to get the desired behavior of my app. It's a good question, though. Any other questions I can answer in the final few minutes? Any other questions? So on Thursday, just to give you a brief sneak preview, you're going to be using an API that we created, actually, especially for this class, that deals with various kinds of products that we want, are selling in some kind of an online marketplace. And so what you're going to do is work through the code that's going to query that database, pull down product information, parse the JSON to grab out the appropriate pieces of that product information, and then display a list of products to the user of your app so that they can browse the different things that you have for sale. That's the goal for Thursday. If there aren't any other questions or anything else you guys want to talk about, we'll go ahead and, oh yeah, in the back. Oh, I'm sorry. It should have changed that. It's in Urbauer 216, 218. I'll change that right now. Sorry, I should have changed that like a week ago. That's my fault. Go visit Taylor tonight from 6 to 8. He'll be camped out in 218, especially if you have questions about the homework assignment. Thanks, everybody. See you on Thursday.